right, class, this is part 2 of 8A problem set. So let's take a look at number 26. This is kind of a long one, so I'll try and do this one quickly, but still cover everything so there's not much of a confusion. So this is called a Born-Haber cycle, and what this does is this explains how we go from, so we're going to start off with calcium as a solid and bromine as a liquid, and then we're going to change that into calcium bromide as a solid. Now you can see the reactants on the left-hand side, reactants over here. There we go. Reactants on this side, products on this side, but there's a lot more to it. So oftentimes in science what we do is we show you like the quick, easy, but that doesn't explain everything. So here's the actual step-by-step process of changing calcium into something that can combine with changed bromine so that we can form the products on the right-hand side. So the first couple of things we need to do first is we need to change calcium from a solid. Notice here it goes from calcium as a solid to calcium as a gas. Now what is this? When you go from solid to a gas, this is called sublimation. Sublimation means that you are breaking the bonds that force calcium to stay in a solid phase. And when we break bonds, that's what the B is for here. When we break bonds, let's get rid of this. Come on. Okay. This is fun. When we break bonds, we absorb energy. When we form bonds, we release energy. That's how we remember it. That's what BARF stands for. Break bonds absorbs energy. Forming bonds releases energy. Okay. So if we break bonds, we're absorbing energy, which is endothermic, which means we're sucking energy in and it gets cold. So it takes energy to change from anything from a solid to a gas, which is sublimation. So that's our first step. After we change calcium from solid to a gas, then we change bromine from a liquid to a gas. Now this is evaporation. Okay, evaporation is the same thing as sublimation as far as it takes energy to pull the liquid molecules apart from each other and force them into a gaseous state. So breaking bonds absorbs energy, which is endothermic. So far, I'm adding energy into the system. I haven't received energy yet. So calcium goes from as a gas to now this is the first and second. This is what you see over here. First and second ionization energy means I'm ripping electrons off of calcium. That takes energy. So again, ionization energy is another case where I am putting energy into the system. I'm putting energy into calcium to rip off the electrons. So I rip off 2 electrons, so I end up with calcium with a +2, and the outside 2 electrons are separate from now calcium. So here's where I go from bromine. My next step is bromine as a gas. I'm going to change from bromine as in Br2. So what happens is that Br has a bond with Br like this. I break the bond here like that. That takes energy. Remember, breaking bonds absorbs energy. And then what I have on the right-hand side here are just a bromine plus a bromine, which means that they are separate, no bond in between the two of them. Still in the gas, though. That, anytime you're breaking bonds, that is endothermic. So far, all I'm doing is dumping energy into this reaction. Okay, now I'm sure to get a return from this. I'm sure to get energy out of it. And one of the places where that happens is called electron affinity. When there's 2 bromines and I have 2 electrons, so now I'm down at this step here. 2 bromines and 2 electrons. Electrons that attach itself to bromine actually gives off energy, which is why I called this exothermic. Okay, so the last 2 steps are going to be huge, huge exothermic steps. So what happens at the end? Well, at the end, I take my +2 that I got up here for calcium, and I take my 2 bromines that are each a -1 that I got from here from my electron affinity step, and I put them together and I form what's called, this is actually called lattice energy. Lattice energy is, that's an I, not an A. Lattice energy is when bonds are being formed and energy is being released, and it's a lot of bonds to make like a grid-like structure. So that is the big exothermic jump that gives off a lot of energy. What we end up with then is something that is less in energy than what we started with, which means that overall, even though we have multiple smaller steps that we had to put energy into, overall energy is given off in this reaction, and that's why the reaction works. Okay, that's a excuse me, that's a really long explanation for a whole bunch of steps for a pretty simple synthesis reaction. Calcium plus bromine gives us calcium bromide. Thank you.